Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. So in today's lecture, we will discuss about the expectation or the mean of a random variable, right? So what is basically expectation? Let us understand that. Now, suppose in a game of chance, we have a chance of winning xi rupees with probability p of xi for I equal to 1 to up to n. What will be our average winning per game? So look at this example and maybe I'll give you some few real life examples. Suppose in a casino, you went and then you have 50 rupees. Winning probability of 50 rupees is maybe P of 50 rupees is equal to, basically if you have maybe 1 by 4, correct? And your probability of winning maybe 100 is, it is given as 1 by 2, and then rupees 200, it is a probability maybe again 1 by 4. So if you go to the casino, you will have that either you may win 50 rupees with probability 0.25, you may win 100 rupees with probability 0.5, and you may win 200 rupees with probability 1 by 4. Correct? So these are the complete list of these three things. Among these three, one will happen, right? So then what will be your average winning per game? If you go to this casino, what will be your expected winning chances? So it is, you think of it as a weighted average kind of a thing, right? So with weight is there. So the probability of winning 50 rupees, what is the weight? With probability 1 by 4. So weighted average, how we calculate? So it is the 50 and its weight, which is the probability of winning 50. So 50 into 1 by 4 plus 100 into 1 by 2 plus 200 into 1 by 4. So all this quantity we multiply with their weight, which is basically a probability here, and divided by, in general we have by their total weights, so which is 1 by 4 plus 1 by 2 plus 1 by 4, and therefore we can calculate it. We have the above one, like if you just calculate, it is 50 plus 200 plus 200 again, so it is 450 rupees divided by 4, right? And if you just again simplify it, we'll have 2 to 5, and it is 112.5 something. So if you go to this casino, your average winning per game will be 112.5 rupees, right? And you see that the denominator, which is the sum of the weights, it is basically the sum of the all probability mass function, quantities of probability mass function, so which is always 1, right, in this case. So if you understand this problem, which is basically you are calculating the weighted average, now you come to the this example, that in a game of chance we have the chance of winning xi rupees with probability p of xi is equal to, basically we have summation of xi into p of xi and divided by sum of p of xi. summation over I. But this sum of x p of xi is always 1. This quantity is always 1. Therefore, this should be your answer. So this is the expected value of the amount to win. Correct? So this is actually called the expectation of a random variable. Now come to the definition of a random. If x is a discrete random variable having probability mass function p of x, then the expectation or the expected value of x, it is denoted by e of x, is defined by e of x equal to summation of x into px, where this summation is over all x, where px is greater than 0. Right? So basically, you have the random variable. It will take some values, right? In probability, like the random variable where we have defined in one of our example that, okay, you are throwing 2 dice. Then random variable was taking some values, right? Maybe 2, 3, and up to 12. So this expectation of x is the weighted average of these values, where weight is the probability of this event, weights are this probability. I hope it is clear. Now we'll do some example. So this part we have already discussed. The expected value of x is a weighted average of the possible values that x can take on, each values being weighted by the probability that x assumes it. Yes, that's what we discussed. Now look at this one. Suppose the probability mass function of a random variable x is given by this one. So here x takes the values either 1 or 2. And probability of x equal to 1 is equal to 1 by 2. And probability of taking x equal to 2 is also 1 by 2. So in this case, both the probability of having x equal to 1 is 1 by 2. Probability of x equal to 2, it is also 1 by 2. In this case, what is your expected value? Let us calculate. We can easily see. So expectation of this x is equal to 1 into probability of 1 plus 2 into probability of 2. So it is 1 by 2. So basically it is 3 by 2 and this is 1.5. So in this case, it is our actual average, right? Now see why this is the actual average, because the probabilities are same. Both the cases probabilities are same. So in this case, weighted average is actually coming up like a normal average of this number 1 and 2, right? On the other hand, if you just check this values, the probability of getting 1 is 1 by 3 and probability of getting 2 is 2 by 3. So the random variable is same. It will take the values 1 and 2. In this case, what will be the expected value of x? Let us calculate. We can see. So it is not normal average. In this case, it is the weighted average kind of thing. So it is 1 into 1 by 3 plus 2 into 2 by 3. And if you calculate, you will get it is 5 by 3. And whose value is 1.667. Now you understand. So this is the weighted average of these two number 1 and 2, where weights of 1 is its probability, weight of 2 it is its probability. And therefore we got the expected value of this random variable is 1.667. I hope it is clear now. Okay. So that is what we have discussed. The whole solution is just given. Okay, let us do one more example. See, suppose X is the outcome when we roll a fair die. Find the expectation of this random variable. So here X is a discrete random variable which is the outcome that we roll a fair die. So one fair die we are rolling, what is our outcomes? So the random variable X will take which values? It is 1, 2, 3 up to 6. It has only 6 outcomes, and because X is the direct outcome, so it will take either 1 or 2 or 3 or 4 or 5 or 6. Now let us also check what is this probability of getting this random variable. That means probability of capital X is equal to 1. So what is the probability that you will get in the rolling of dice? The upper face is 1. Yes, we all know it is 1 by 6 because it's a fair die. In the same way, we can have P of 2 is also 1 by 6. In the same way, we can also have that P of 6 also 1 by 6. All the values are 1 by 6. 1 by 6. Now, in this case, what will be the weighted average of this number 1, 2, 3 up to 6? Because all of them have the same probability, so therefore expected value of this X is equal to 1 into 1 by 6 plus 2 into 1 by 6 plus you have to see 6 into 1 by 6, right? And if you just simplify it, you will get it is 7 by 2, and which is basically 3.5. So this average here, because all of them have the probability 1 by 6, so it is actually just average. So if you roll a fair die, your expected value is 3.5, right? So this 3.5 is the expected values of these values, which, which are the random variable which takes these values. Clear? Okay. Let me give one more example. Yeah, this one we have already discussed. Let me give you another example. Now, suppose a cumulative distribution function is given for a random variable x, which is given by, all of us know that the cumulative distribution function is denoted by fx, capital Fx, and it is given for these values. So from this question, what we understand, we have already discussed this kind of problem in the previous lecture, where we have discussed the cumulative distribution function. Yes, the random variable takes which values? From this function, we can easily understand it takes the values 0, 1, 2, and 3. Right? So what we have to do to get the expectation of this random variable? So basically, we have to find the average value, weighted average values of these values with certain probability. But to know that, we need to find the probability of this value, that random variable takes the value 0, or p of 1, p of 2, and small p of 3, which is basically the probability mass function of this random variable. So from cumulative distribution function, or from the distribution function to probability mass function, how we calculate? We have already discussed this one in a previous lecture, right? If you do that, we can easily get the probability mass function is given by this function. So we have already solved this example, and therefore the expectation is what? So expectation of this random variable will become p of x is equal to, it is 0 into p of 0, which is 1 by 2, plus 1 into p of 1, which is 1 by 6, plus 2 into p of 2, which is 1 by 4, plus 3 into p of 3, which is 1 by 12. And if you just simplify it and calculate, you will get the values is 11 by 12. Right? So which is the basically the weighted average of these numbers, where the weights are their probability. Weights are their probability. So this number is lies between them only. You can check, it is lies between 0 to 3. I hope it is clear. Okay. Now we have a result, which is basically a theorem. It has a big proof, but we don't need the proof. Just to understand one thing, if I have x is a random variable, then for any real valued function g of x is again a random variable, right? And not only that, how do you calculate the expectation of this random variable g of x? It is expectation of g of x, which is a random variable. It is the summation of small g of xi into pxi. Our summation is over I, right? So that means the random variable has changed. It is g of x. So functional values of this random variable. So this g of x takes which values? It will take the values g of xi, right? Where the i's are that I which gives you the random variable x1, x2, xn, that i's, right? So g of xi into p of their probability will be as it is, the same as p of xi. Clear? So therefore, this theorem says if x is a discrete random variable that takes one of the values xi with respective probability p of xi, then for any real valued function g, expectation of g of x is equal to gxi into p of xi. Right? Now this is a very useful proposition, very useful result that we can use it in several places. Let us have an example. Look at this one. Let x is a random variable that takes on any of the values -1, 0, and 1 with respective probabilities is 0.2, 0.5, and 0.3. Then you have to calculate the expectation of x square. Now this x square is actually a function of x, capital X. It is g of x is x square, right? Now how to calculate? So expectation of x square I have to calculate. So expectation of x square is what? It is summation of x square into xi square into p of xi, right? Because here g of x is x square, capital X square. So g of xi is xi square. So if I have this, I will have expectation of x square. Maybe I'll do it here. So it is -1 square into its probability, which is 0.2, plus 0 square into its probability, which is 0.5, plus 1 square into its probability, which is 0.3. Right? And if you just simplify it, what I'm getting? So if you simplify it, it is 1 into 0.2 plus 1 into 0.5. So it is 0.5. 1 into 0.2, here it is 0, and 1 into 0.3. So 0.2 plus 0.3, it is 0.5. Right? So if your random variables, what value it takes, if it is given m, if it is probabilities are given, we can find the expectation of any real valued function. If it probabilities like probability of the event xi is p of xi, then we can take these values. Now let us see one observation. Let us check what is the expectation of x. So e of x is what? So it is the summation of xi p of xi. So it is -1 into 0.2 plus 0 into 0.5 plus 1 into 0.3. And again, if you just calculate, so it is -0.2 plus 0.3, so it is 0.1, right? And therefore, if you just see one observation, E of x square is what? E of x whole square. This whole square is equal to what? It is 0.1. Sorry. So it is 0.1 whole square, which is 0.01, and which is not equal to expectation of x squared. Right? So what we observe? E of x whole square is not equal to E of x square. Right? And in general, we have that E of gx is not equal to g of ex. I hope it is clear. Okay, next. Next, we have a small result related to the expectation of a random variable. So if a and b are two constant terms, then expectation of ax plus b is equal to aex plus b. So it is kind of a linear, right? And this proof is actually very easy. How we can do it? So expectation of ax plus b is equal to, so according to the definition here, the gx function is ax plus b. So we'll have summation of axi plus b into p of xi, where summation is over. But according to the summations definition, this a is a constant term, b is a constant term. So it is a into summation of xi into p of xi. Summation is over I plus b into summation of p of xi. Summation is over I. Now what is this quantity? This is expectation of x. So it is a into e of x plus b into what is this quantity? It is the sum of the probability mass function, that all the values random variables, the probability sum. It is 1, so it is b into 1. So therefore we can get it is a into e of x plus b. So expectation of ax plus b is equal to aex plus b. Right? So it is a kind of linear type. So if you add two random variables, we can have their expectation, just you can divide it in this way, right? So this proof we have already discussed. Now let us do one example. Now this is a discrete random variable is given whose probability mass function is also given, right? And we can see that this random variable x takes the values. The random variable x takes the values. What are they? 0, 1, 2, and 3. Now you have to find the expectation of x square plus 2x plus 3. But we already have seen that this is linear type. So e of it is equal to e of x square plus 2 into e of x plus 3. Now this problem we can do it in two ways. One, what we are doing it right now, and another one I will discuss this after doing this. So we can do in this way. So because it is linear, so it is e of x square plus 2ex plus 3. Now let us calculate one by one. What is e of x squared? We have already done such kind of thing earlier. So it is 0 square into probability of 0, which is 1 by 2, plus 1 square into probability of 1, which is 1 by 6, plus 2 square into probability of 2, it is 1 by 4, plus 3 square into probability of 3, it is 1 by 20. And if you just simplify it, we'll get the values are, this value is equal to 23 divided by 12. And the same way, what is the expectation of x? It is 0 into 1 by 2 plus 1 into 1 by 6 plus 2 into 1 by 4 plus 3 into 1 by 12. And if you calculate it and if you simplify it, we'll get the values is 11 by 12. And therefore we have this e of x square plus 2x plus 3 is equal to 23 divided by 12 plus 2 into e of x, which is 11 by 12 plus 3. And if you simplify it, we'll get it is 27 divided by 4. So we can calculate the expectation of some variable like this by using the linearity of e of x. Now this one we can also do it by using the proposition which we have discussed just a few minutes back, using this proposition. Why can't we do that one? Because in this case e of x square plus 2x plus 3, it is actually g of x now. So suppose I have a function which is g of x is equal to x square plus, just a second, I have a function g of x. Okay, just a minute here. I have a function g of x which is x square plus 2x plus 3. Now you find out the functional value of each of the random variables. Now random variable was taking the values as 0, 1, 2 and 3. Now what is g of 0? It is 3. G of 1, it is 6. G of 2, it is 4 plus 4, 8 plus 3, 11. And G of 3 is equal to 9 plus 6 plus 3, so 18. And therefore expectation of g of x, which is actually expectation of x square plus 2x plus 3, which should be the, according to that theorem, it is summation of over I g of xi into p of xi. But these values is g of xi means 3 into probability of 3. What is the probability of g of 0 into probability of 0, which was given as this way. Just a second. Yeah, so g of 0 is 1 by 2, p of 0 is 1 by 2, p of 1 is 1 by 6, this is 1 by 4, and p of 3 is 1 by 12. So if we apply these things, we'll have this value is g of 0 into p of 0, so 3 into 1 by 2 plus 6 into 1 by 6 plus 11 into, what is the probability of at the point 2? It is 1 by 4, and plus 18 into probability at the point 3, which is 1 by 12. And again, if you calculate it and if you simplify it, we'll get this value is 27 by 4 again. So we can do that problem in two ways. One is by applying directly this formula, or one can do it just the break of this summation. So you just break it with e of x square plus 2 into e of x plus 3 and calculate separately e of x square and e of x and substitute the value. So both the methods are correct. So you can apply according to your convenience, right? So let me end the lecture for this. In the next, we will discuss that the variance of a random variable, right? So all the lectures, all the content of this lecture, we have taken mostly from this book, Seldom Loss, and other books also we have followed. So if you like the video, please do comment. If these videos are helpful, please write down in the chat box. Thank you very much. We'll meet in the next lecture.